Part 2 of discussion for one-dimensional and two-dimensional array. Array as parameters to a function. Take note that arrays are passed by reference only, so that means we do not use the ampersand sign symbol in declaring an array as a formal parameter. And the size of the array is usually omitted when it comes to array as parameter to a function. If provided, it's still ignored by the compiler. For example, 9-6, the first declaration or definition of a function using the array as a formal parameter. Since we are talking about that an array parameter is passed by reference, we always use the data type void. Then the next one is the name of the function, which is, in this example, we call it as initialize array. And then followed by the parentheses. Within the parentheses will be the parameters. The first parameter is a pass by reference, which is an array parameter, since there is a subscript on it. And the second parameter is just a simple variable. So the first one is the pass by reference for an array as a formal parameter. And the second parameter is just a simple variable, which is a pass by value. The next definition of an array uses a constant array as formal parameter. So you may or may not use the word const in declaring the array as formal parameter. So you know already what's the definition of const. Const, if you are going to include const, it means that the value or the size of the array is fixed and you cannot change it during the execution of the program. The base address of an array is the address or location of the first array component. So please take note that always we started the first position or the first array component in position 0. So let's say, for example, if we have an array named list in a one-dimensional, its base address is the address of list subscript 0, meaning that is the first position or the first address of the location. So when we pass the array as a parameter, the base address of the actual array is passed to the formal parameter. So when we pass it with a list subscript 0, then it will be passed to the formal parameter, same as base address of list subscript 0. This is just an illustration of the base address of an array, which is on the left, my list subscript 0 up to my list subscript 4, and the array in computer memory, which is the memory addresses within the system. Examples are 1000, which is actually the address of my list subscript 0, 1004, the address of my list subscript 1, and so on and so forth. Please always take note that C++ does not allow function to return a value of type array. We always use a void data type because, again, function cannot return a value of the type array. C++ also allows any integral data type to be used as an array index. For this example, we use green, red, blue, brown, white, orange, and yellow instead of 0, 1, 2, 3, and so on and so forth. But in this case, we do not use a data type int, but instead we use the data type enum. Enum means enumeration data type. So we declare it as enum paint type. Paint type is the name of the variable that will represent the enum value. Then we're going to make use of that instead of the position or the index 0 to positive n. So if you're going to take a look at the looping statement, we use the paint since paint is the object of paint type and paint type includes green up to yellow. So we initialize the value of the object paint equals to green. And if you're going to take a look at the second expression for the for loop, paint is less than or equals to yellow because yellow is the last position from the paint type and enum type data. This is just an example on how are we going to apply or implement one-dimensional array. So we're going to do searching on a separate program using C++. For a two-dimensional array, whatever we applied from one-dimensional array also applied into two-dimensional array. So again, it is a collection of a fixed number of components that this time arranged in two dimensions instead of one. It is also sometimes called as matrices or tables. So the declaration or the syntax on how are we going to declare a two-dimensional or a multi-dimensional array is data type, and then array name followed by two subscript. That means we are talking about two-dimensional array. The first subscript will be for the row, and the second subscript will be assigned for the columns. This is an illustration of a two-dimensional or a multi-dimensional array. A two-dimensional array or a multi-dimensional array, in this example, we call this as an array cells. If we're going to take a look at cells, there are rows and there are columns. So two-dimensional array means that we're going to get the value for rows and the value for column. And please take note that since this is a two-dimensional array, we're going to get all the positions from the rows and the column. And the first position of the row and the column must be at position 0. In accessing array components, or if you want to assign values in a two-dimensional array, so we need to use this syntax. Array name, and then the two subscript for the rows and for the column. So let's say, for example, we want to assign a value in the first position of a two-dimensional array, and the array name is, for example, list. So we're going to access it by using the list. The first subscript would be 0, and the second subscript would be 0. So that means list subscript 0, subscript 0. It's either you may use the assignment operator equal sign, or you may also use the cin for the input statement. Let's say, for example, again, we have the cells, and cells contains address for rows from 0 to 9 and address to columns from 0 to 4. So that means we have cells, subscript 10, subscript 5. That means there are 10 rows and 5 columns. So let's say, for example, we want to assign 25.75 in row 5, column 3. So we're going to access it by using the name of the array, which is cells, and then followed by the two subscript. The first subscript must be assigned in the row, which is row subscript 5, and the second subscript will be assigned for the column, and the column must be subscript 3. We can also initialize the value or the elements of a two-dimensional array during the declaration. Let's have this example. We have an array named board, and we have a size of row which is equivalent to 4 and a size of column which is equivalent to 3. So if you're going to take a look at the size of the array, that's already equivalent to 12 elements. So we assign an equal sign since this is a declaration, followed by the curly braces. So in this example, we have 231. That 231 will be assigned on the row 0, and 2 will be assigned at column 0, 3 will assign at column 1, and 1 will be assigned at column 2. For the next one, which is 15, 25, and 13, that will be assigned in row 1, that is column 0, which is 15, column 1 is 25, and column 2 is 13, and so on and so forth. Elements of each rows are enclosed within braces and separated by commas. Take note of that. And all rows are enclosed within braces. For number arrays, if all components of a row are not specified, Unspecified ones are set to 0. So that means if we do not initialize the entire size of the elements within an array declaration, the rest of the elements will be initialized also to 0. To process two-dimensional array, we need to have the following. We need to process the entire array. We need to process also the particular row of the array called row processing, as well as particular column of the array called column processing. So take note that each row and each column of a two-dimensional array is a one-dimensional array as well. So to process, we're going to make use of the algorithm similar to processing the one-dimensional array. For this example, we use the word const to fix the value of the size of the rows and the columns to 7 and 6. But this can be set also to any number after running the code. Then we have a declaration of named matrix as your array in a two-dimensional, and you use the number of rows and the number of columns in your declaration for the constant. Then we have also a variable row for the index of row, a variable column for the index of column. Then there are still another variables that will maybe compute for the sum, getting the largest value, and a temporary variable. So in figure 9-15, it shows the array matrix. So the name of the array, two-dimensional array, is matrix, and the size of the column will be 0 to 5 since the size is 6. We started it at position 0 and ends it at position 5. And the size of the row, we have 7. So we need to start the position or the address to 0 and ends the address to 6 since there are 7. Let's say, for example, we want to initialize only the row number 4 to 0. So how are we going to do that? So we need to first assign the value of row equals to 4 so that the compiler of C++ will just initialize the value on that particular row. Then we're going to make use of a one-dimensional looping statement. But if you're going to take a look at the initialization within the looping statement, we use two subscript, which is for the row and for the column. So since we already assign and initialize the row in number 4, then we're going to populate only the entire column of row number 4. So again, we're going to make use of a looping statement, initialize the value of the column to 0. Then we're going to do the expression of column wherein we need to put less than number of columns. If the number of columns is 7, so it must be column less than 7. If the number of columns is 5, so it should be col less than 5. Then increment or alter the value of column by 1. Then we are going to assign the value of 0 to, since the previous example is matrix row, subscript col is equals to 0. So that means row is always 4, and then the column will be initialized from 0 to the last position of the column. If the last position of the column is 6, so that means matrix subscript 4 subscript 0 will be initialized to 0. Matrix subscript 4 subscript 1 is equals to 0. Matrix subscript 4 subscript 2 is equals to 0, up to matrix subscript 4 subscript 6 is equals to 0. But if you want to initialize the entire matrix to 0, so you need to use a nested loop instead of a single loop. So there will be two loops. The first loop is the outer loop, and the second one is the inner loop. So for the outer loop, we're going to make use and assign it for the row, and the inner loop will be assigned for the column. And then, same thing as what we did in initializing the row number 4 to 0, we always use the name of the array. In this example, we use matrix, and then we use the subscript row, subscript column for the index of row and index of column, and assign it to 0. If we want to display or output the components of matrix or the two-dimensional array. So again, we're going to make use of the nested loop, and then within the inner loop, we're going to display the value of the matrix. This example, we have matrix subscript row subscript column. That means we're going to display the entire elements within a two-dimensional array. Cout NL means next line. To output the next columns on the next line and the next row on the next line. If you want to input data, or if you want to prompt the user to input data into each component of the matrix, again, instead of using cout, you may use cin, and then the greater than sign operator, and then again the name of the array, and the two subscript assigned for the row and for the column. Two-dimensional array as parameter to a function. Two-dimensional array can be passed as parameter to a function. Same thing as one-dimensional array. It is passed by reference. Base address is passed to a formal parameter. And the two-dimensional array are stored in row order. So take note, when declaring a two-dimensional array as a formal parameter, you can omit the size of the first dimension, which is the row, but not the second, which is the column. Example of a two-dimensional array as a parameter to a function. If you're going to take a look at the last portion of the bullet, void means it is passed by reference. Array list is the name of the function. Inside the parentheses will be your parameter to a function. So since we're talking about two-dimensional array, matrix is a two-dimensional array composed of two subscripts. So take note again, when declaring a two-dimensional array as a formal parameter, we can omit the size of the first dimension. So that's why we only use the subscript. We do not include any variable within the subscript. Only on the second subscript, we assign the value of the variable column, since again, we can only omit the size of the first dimension, but not the second dimension. Two-dimensional is already considered as a multi-dimensional array, but when we say multi-dimensional array, it is also a collection of a fixed number of elements called components arranged in n dimension. So that means if your n is greater than or equals to 1, that's already a multi-dimensional array. It is considered as a multi-dimensional array, or we call it as n-dimensional array. So in this case, if it's already like a multi-dimensional array, we always add subscript. So if you're going to take a look at the declaration syntax, we have the data type, we have the array name, and followed by subscripts. So if that is just a one-dimensional array, we only use a single subscript. For two-dimensional array, we have two subscripts. But since we're talking about multi-dimensional array, we also include another subscript. So in this example, we have three subscripts. So that means it's already considered as a multi-dimensional array. So it's just like assigning the value of x, y, and z. So it's just like a cube. And to access the component, again, same thing as what we did and what we apply from one-dimensional and two-dimensional array. If this is a three-dimensional array, that means it is already like having a three subscript. When we are going to access the component or assigning values or accepting input values with that particular array, so we're going to access it with the array name followed by the subscript. If that is three-dimensional, we have three subscript. So usually, if that is already a three-dimensional, the first the first subscript will assign to 0, second subscript is 0 again, and the third subscript is also 0. So we can also like 001, 002, 003, 004, or 010, 011, 012, 013, and so on and so forth. So take note that when we are declaring a multidimensional array as a formal parameter to a function, again, we can omit the first dimension but not the other dimension. So if your multidimensional array are composed of 3 dimensions, you can omit the first dimension, which is the row, but the column and the third subscript, you cannot actually omit that. And as parameters, multidimensional arrays are passed by reference only, so that means you always use void data type. A function cannot return a value of the type array because, again, it is already a pass by reference. And there is no check if the array indices are within bounds or out of bounds.